Hey guys, what is up? This is the second part of my pedestrian detection videos. In the last video, I used hard cascade classifiers from opencv to classify pedestrians. But as you can see in the previous video, it wasn't really good. Although it, I should say, detected some people in the photos I gave it as an input, it was not really as cool as we expected. So I decided to use YOLO version 5 or deep learning. YOLO is simply a deep learning tool called You Only Look Once, and it is used for transfer learning and making custom classifiers. What is transfer learning? It's simple. It's basically teaching you or any other living creature or even not living creature like a computer to learn based on their existing knowledge. For example, I speak Persian. When I was learning English, one of my teachers told me there is a word called bazaar in the English language, which is the same in Persian, and it's actually rooted in Persian language. We call markets in our language bazaar, and there is bazaar in English. And then teacher started teaching us, the students, with different words that mean the same thing, or at least mean the same thing in our minds, like the market, shopping center, or the mall. So I have trained a very simple and basic model for detecting pedestrians in a photo or a video clip. So in this video, we are going to simply use my trained model of pedestrian detection. So let's not waste any time and get right into our project. Okay, I'm here on Google Colab and I'm going to just write the codes I wrote for this particular project. But before doing anything further, I should say my neighbors are renovating their home, so there will be some unusual sounds in my background. And the reason is I'm too lazy to just plug in my studio microphone to my laptop before recording any video. I'm using a GPU runtime on Google Colab. The reason is it's faster on GPU, and I think I haven't ever used GPU in projects I showcased in my YouTube channel or even on my GitHub repositories. The main reason is I didn't have any GPUs in a long time. But for now, I can use the GPU from the cloud, from the Google Colab. Okay, so first thing we need is checking the GPU model we've got. This is a Tesla K80, and if you want my opinion, it's more than enough for the purposes like detecting a text or a particular person in an image. So you usually get Tesla K80. You may get other models as well, but this is more than enough, at least for me, in this particular project. There is an error here, and I don't care about this error. So first, let's install Pytorch, which is our key dependency in this project. I'm here in pytorch.org/get-started/locally. I'm not sure, but there is a probability of Pytorch being installed on Google Colab servers, so do not worry about that. But if you want to do it on your machine, I use the stable build. I use Linux because on Colab we have Linux, and I use Python language, not C++, not Java, and I use okay, I have to find the CUDA version. It's 11.2. So I think we get this one, and let's copy this code and simply paste it here. And we don't need this tree here because Google Colab gives us an isolated environment itself. So we don't really need to specify the version of Python or any other thing we are using. And I run this code. It starts downloading and installing Pytorch for us, which is really cool, especially with the speed I get here. It's almost 2 gigabytes. Okay, so what are the other dependencies we need? The first dependency I really need here is a pedestrian's photo, which is the photo of the Beatles walking on a crosswalk. So we have it here, and we are doing some opencv magic here as well, as long as our Pytorch has been installed. And actually I have my cheat sheet here. So these are things we really need to have in our project. This is a notebook for one of my oldest projects, but for now I'm only using some of these project files actually. Let's not get distracted. And here we are in our Colab notebook. Okay. We already had Torch on our Google Colab, but hey, it does not hurt if you install some of the dependencies over and over again. At least we have the right versions of our need here. Fine, our dependencies are just installed. So let the code begin. First of all, I'm going to find the working directory, and I'm going to make sure I have everything here. I have a best.pd. This pt file is actually my weights for the model I have trained. So what I'm going to do is to change this best.pd, okay, to pedestrians.pd. And here it should be changing. If I just list my directory again, we see pedestrians.pd. Actually, let me go up and down. You see pedestrians.pt. So this is the very first thing we are going to do, having our weights file with a proper name. Then I say import torch, import matplot library.pyplot splt, import cv2, and import numpy as mp, and we wait. So I need a model now. What is my model? Okay, I need an image to classify. So what I'm going to do is opening my image, cv2.imread, pedestrians.jpg, and after that, plt.imshow cv2.cvt.color image cv2.color bgr to RGB. Okay, we've got our image. Now I know how I can work with the image I have in the Jupyter notebook. In case you don't know, you can't directly use cv2.imshow in a Jupyter notebook or a Google Colab notebook, which is basically the same as a Jupyter notebook but on a server, on a cloud. And I need a model. My model is torch.hub.load. And if I'm going to see my cheat sheet here, this is how it works. So first I give the address Ultralytics YOLO v5. I give it the custom parameter, and it means I'm using a custom model I have trained on this thing. Then we give it a path, and my path is pedestrians.pd, and then we have, let me check, force reload equals to true. It just downloads everything needs for loading this model, and as you can see, it also installs the needed requirements. It was much better if I did it first. Okay. It says restart the runtime or rerun command for updates to take effect. So here, let me go to runtime and restart the runtime. And we are waiting here. Okay, our runtime has been restarted. So here I just say result is equals to model pedestrians.jpg, or even better, we can say model image. The model is not defined. You know why? Because we have to run everything we had. So here I prefer to start running from here. It's not important. I'm running everything here. I'm running it here. And I'm running it here. And I'm running our cell again. So if I say result.print, it detected 2 pedestrians. So let me save it to result image. And if I see here, okay, I have mp.squeeze result.render, and then plt.imshow result image. As you can see, it only detected 2 of pedestrians in this image. Why is it like that? Okay, the reason is very simple. My dataset was very small and I did not really put too much time in detecting a good amount in training with too many different photos. Something I really needed was something like the fancy video at the beginning of this tutorial, and it worked perfectly with that. It was only 5 times of running the YOLO v5 algorithm, I should say, on my dataset, but it is pretty good. If we view this image in a new tab, the confidence level is a little bit more than 0.5, which is really enough. So something I really am curious about is what is inside this result. We know how it works now, and we can digest it further for other tutorials. So guys, let me just review what we've done. First, we used a GPU runtime and we checked the GPU. Second, we installed our dependencies from this tutorial from Pytorch library. Then we checked out if our files are all set in their own places. Then we just imported everything we needed, like matplotlib, like cv2 or numpy. Remember, if you use Anaconda on a Windows machine or if you use Google Colab, most of these things are already installed for you, so you don't really have to install them. But if you use a bare metal machine or you use Python, I shouldn't say bare metal, if you use Python installed on a Windows or Mac or Linux machine without Anaconda, you have to install all of them one by one. Then we opened our image and then we made sure that our image has been loaded. And then we loaded our custom model using Torch Hub. And remember, you need internet connection for this thing because we are just finding the prerequisites of this detection model from GitHub, and make sure you have proper access to GitHub. So if you need some sort of proxy or VPN to access GitHub, make sure it is working. And then we just loaded our image to our model and we simply said print the results for us, and we found out 2 pedestrians and we just rendered the resulting image. So guys, this was the whole process and I hope you learned something new with this project. In the next videos, we will learn how to train our own model using YOLO v5 or YOLO R. I don't know, it might be very fun to use different algorithms to do object detection. And until the next video, stay safe and I see all of you guys in the next video.